it's known that under the standard treatment for a certain disease, 9.7% of patients with the disease experience side effects within 1 year. In a trial with a new treatment, 450 patients with this disease were selected, and the number X that experienced side effects within 1 year was noted. And it was found that 51 of the 450 experienced side effects. This is hypothesis testing. We're asked to test at this 10% significance level where the proportion of patients experiencing side effects is greater under the new treatment than under the standard treatment. So H0 is that P is 9.7% or 0.097. This is the proportion experiencing side effects. Or I should actually say the probability of experiencing side effects. And then H1 is actually that it's gone up under the new treatment. Okay, that's the information in here, whereas it is greater. So P is greater than 0.097. Now, actually, X has already been defined. So normally I always say, let's define what X is, but we're told that it's the number who experience side effects within 1 year. So I'm going to assume H0 is true. Okay, then I can actually construct a model. X will follow a binomial distribution, and we're testing 450 people, so that is the number of trials. Probability of success as such to experience side effects is 0.097. And then it was found that 51 of the 450 experienced it. So let's work out the probability of those 51 or more than 51. It's really important that we don't just look at the 51, but we look at 51 or more. And that is going to equal 1 minus the probability that X is less than or equal to 50. Okay, because this is the bit that you can put into your calculator, the cumulative distribution where it's less than or equal to. So we want to include 51, and therefore we subtract all the values below it. Right, oh, I've already got a binomial distribution up from a different question, so it's going to be binomial CD, and I'm going to use variable. This is 450. Sorry, no, it's not. This is 50 because I'm minusing the 50, so this is going to be less than or equal to 50. This is 450, and then we've got 0.097, and I get 0.8616. So 1 minus 0.8616, which becomes 0.138 to 3 significant figures. Now that is our probability. It's about 13.8%. So it's actually reasonably high that this could have happened. And in fact, it is higher than the threshold, this 10%. So we're saying there is enough chance that it could have just happened due to natural variation. And therefore, we are actually going to accept H0. I'm going to write that in there though. So there is more. This is like, you don't need to write this. It's just, I'm just trying to explain it to you. There's more than a 10% chance that this would happen. Through natural variation. Therefore, we actually accept H0. Wait a sec. No, we don't accept H0. I always mess this up. We do not reject H0. You get the mark for writing accept H0, but we never quite accept it. We just say that we can't, there's not enough evidence to reject it. Okay, you need to give context. Not enough or insufficient evidence that the new treatment. Actually, forgotten what we were doing. The new treatment causes more side effects, causes more people to have side effects. Okay, there we go. Good. Got to get all these little steps in. H0, H1, probability, compare it with the significance level, accept or, sorry, reject or do not reject, and then give some context. Part B says it was later discovered that all 450 patients selected for the trial were treated in the same hospital. Comment on the validity of the model used in Part A. So there's an issue here, the fact that they're from the same hospital. You have to have very, strict circumstances for a binomial distribution. And so I said the cases are not independent. Okay, remember, binomial distribution, you have to have independence between events. They cannot affect one another. That is something that comes out of the calculation. They are from the same hospital. So the binomial model may not be valid.